Hey guys, a very good day to you. Hope you're all doing well. And today we're going to be revising for the physics periodic. Let's read the first question. A particle is moving such that x equals 4t minus 3, y equals 3t squared plus 5, and z equals 7, where x, y, and z are all expressed in meters. Part A. Find the position vector as a function of time. Now I'm going to be stopping for a few seconds. You can all pause the video and solve it, and then I'll start after a few seconds and then you can check your answers. Okay, I'm going to start solving the question. So what they want us to do is find the position vector. We all know the position vector is represented by r with the arrow on top. So this is the position vector equals xi plus yj plus zk, right? And then all of this is expressed in meters. So let's just substitute. You get r equals 4t minus 3, all of it I, plus 3t squared plus 5 j plus 7k, all of it in meters. And that's your first answer. So the position vector as a function of time is 4t minus 3i plus 3t squared plus 5j plus 7k, all of it in meters. So from part A, we got r equals 4t minus 3i plus 3t squared plus 5j plus 7k in meters. So what this shows us is at any time t that we substitute in the equation, we know the exact position of the object. So now part B is what is the initial position. So now I'm going to be giving you again a few seconds, solve it, and then we'll check together. Okay, let's do it together. What is the initial position? The trick word here is the word initial. Let's underline it. Initial means the first. So when is the first position happening? At time equals 0. So in short, the question can be summarized as at time equals 0, r equals question mark. What is r? So let's substitute that in our equation. R at time 0 equals, so wherever we find t, we're gonna put 0 there. So 4 times 0 minus 3i plus 3 into 0 squared plus 5j, and since 7 has no t in it, it's always going to say the same. When we're done solving, we get r0 equals, again 4 into 0 is 0, so minus 3i plus 5j, and as 7 has no t, 7k in meters. So at time equals 0, the initial position of the object is this. So we're using the same given as part A, where we have the position vector, and let's solve part C. Find the displacement between time 1 second and time 2 seconds. So I'm going to be doing the same thing as before. Wait for a few seconds while all of you solve. Okay, let's solve. So they're asking us to find the displacement. So as we all know, the formula for displacement is the change in position. So delta x equals the position at time 2, so r2, minus the position at time 1. We do not divide by time because we're not looking for velocity. So as we all know, we substitute in the formula 4 times 2 minus 3i, all of this in big parenthesis, plus 3 into 2 squared plus 5j, and 7 is the same, 7k, all of this minus 4 into 1 minus 3i plus 3 into 1 squared plus 5j plus 7k, and the answer shouldn't have k because 7k cancels out, which leads us to the final answer. Delta x equals 4I plus 9j meters. So the displacement between time equals 1 second and time equals 2 seconds is 4I plus 9j. So for parts D and D, we'll be using the same given from part C, which is this displacement vector 4I plus 9j. Let's read them both. Part D says, find the magnitude of the displacement vector between time 1 and 2 seconds. And part E says, find the magnitude of the average velocity between time 1 and 2 seconds. So I'll wait for a few seconds, all of you can solve, and then we'll check together. Okay, let's check. As part D says, we have to find the magnitude. It's very easy. All I have to do is do the square root. 4 squared plus 9 squared, which is the square root of 97. Or you can keep it as 9.8 meters. Both work. You can keep it in radical form or you can convert to decimal form. It's your choice. Part E. Find the magnitude of the average velocity between time 1 and 2 seconds. So what is the formula for average velocity? Well, it's displacement over time elapsed. So let's write that down. V equals delta x over delta t. Well, we have the displacement of the magnitude of the displacement, which is radical 97. And we can find delta t, which is 2 minus 1. Which equals radical 97 over 1, which gives us the final answer, radical 97 meters per second. So that's the answer for part E. Let's do number 2 now. A particle is moving such that x equals 2t cubed minus 5t plus 3, y equals 3t cubed plus 3t squared plus 4t minus 5, and z equals minus t cubed plus 2t squared minus 6, where x, y, and z are expressed in meters. Part A says find the velocity at time 1 second, B says find the acceleration at 2 seconds, C says find the speed at 1 second, and D says find the magnitude of the acceleration at 2 seconds. So I'll be waiting for a few seconds. All of you can pause the video and solve the questions, and after a few seconds we'll check together. Okay, so let's start with part A. The very first thing what you're supposed to do is find the position vector. Since they're asking for velocity, we all know that velocity is equal to the derivative of the position, right? So let's find the position. So as we all know, r with the arrow vector notation on top is equal to xi plus yj plus zk, because these are I, j and k are all the unit vectors associated with x, y and z respectively. So all you have to do is substitute. We get 2t cubed minus 5t plus 3i plus 3t squared plus 4t minus 5j plus minus t cubed plus 2t squared minus 6k in meters. But that's not what the question is asking us. First you have to find the velocity. So you have to derive. We get v equals, all you have to do is derive all of this to get 6t squared minus 5i plus 6t plus 4j plus minus 3t squared plus 2k meters per second. But still this is not the complete answer. So what is the question asking us for? Well, they're asking us at time 1 second. So we have to substitute 1 in each of these places where they have t. So after substituting, we can put this as v1 because v at 1 second, and you should get I, because 6 minus 5 is 1, plus 10j plus k. I made a mistake here. It's supposed to be 4, not 2. So plus k. And this is in meters per second. Let's go to part B. Now since we had the velocity from before and they're asking us to find the acceleration in 2 seconds, all we have to do again is to derive the velocity, and when you derive the velocity you're supposed to get 12ti plus 6j minus 60 plus 4k meters per second squared. Again, this is not the complete answer. We have to find a at 2 seconds. So again, all we have to do is substitute, and we should get 24i plus 6j minus 8k meters per second squared. Right, let me just erase that. Let's look at part C. Part C is asking us for the speed at 1 second. Now we should remember that the speed is the magnitude of the velocity. Since we have the velocity at 1 second equal to I plus 10j plus k in meters per second, well then all we have to do is find the magnitude. So the speed at 1 second is equal to square root 1 squared plus 10 squared plus again 1 squared, and that should give us around 10.1 meters per second. All you have to do is find the magnitude. And these again very similar. They're asking us for the acceleration at 2 seconds, the magnitude of the acceleration. So again, all you have to do is find the magnitude of the acceleration vector, which is equal to the square root again of 24 squared plus 6 squared plus 8 squared. The negative you ignore because you're squaring it, everything becomes positive, and you should get exactly 26 meters per second squared. Let's move on to number 3. A body moves along a straight line. Its position from the origin at time t is given by the equation x equals 2t squared minus 8t plus 5, where x is in meters and t is in seconds. A asks us the nature of the motion, B asks us the average velocity of the body in the interval from 0 to 2 seconds, C asks us the velocity at 2 seconds, and D asks us what time is the particle passing through the origin. Okay, let's solve this together. So part A asks us what is the nature of the motion, right? So now we know two types of motion when it's moving in a straight line, right? We know either URM or UARM. I'll give you two tricks to knowing which one is the correct one. So we know it's UARM for sure. Now let me tell you why it is UARM. See, whenever the time is squared, you should know that it's UARM, because when you derive it, let's say you derive it 2t squared minus 8t plus 5. Let me derive it. I get 4t minus 8. This is the velocity. Let's find the acceleration. The acceleration is 4. What is the definition of UARM? The definition of UARM is when the acceleration is constant. Isn't the acceleration constant? So that's how I know it's UARM. Let's move on to part B. Find the average velocity in this interval. We should know that the formula for the average velocity is equal to delta x over delta t, or the displacement over the time elapsed. So let's see, x at time 2 minus x at time 0 over 2 minus 0. So x at time 2, let's substitute. We should get minus 3. We substitute in this equation, this one. And x at time 0 is 5. So minus 5 over 2, because 2 minus 0 is 2. So we should get minus 4 meters per second. Now let's go on to the next one. Part C now. Part C, they're asking us what's the velocity at time equals 2. We should all remember after deriving, I had gotten the equation for velocity to be 4t minus 8. Very simple substitution here. So v2 is equal to 0 meters per second. And now let's go to part D. Part D is the hardest question of all of these 4 questions. At what time does it pass through the origin? Now we know that the formula for the position is 2t squared minus 8t plus 5, right? So now they're asking us what is the time that makes the position 0? At what time does the position pass through the origin, or is the position at the origin? So what we do is we substitute 0. 0 equals 2t squared minus 8t plus 5. We can all plug this in our calculators and get the answer. The only criteria should be that the time has to be greater than 0. And in this case we get 2 times. So time 1 equals 0.78 seconds, or time 2 which equals 3.22 seconds. And that's the answer. So in these 2 times the particle passes by the origin. Let's start question 5, guys. A car traveling at 80 kilometers per hour directly towards a lorry traveling at 30 kilometers per hour. At the instant the vehicles are 55 kilometers apart, a pigeon leaves the car, moving always with a constant speed of 48 kilometers per hour towards the lorry. On reaching the lorry, it flies straight back towards the car, and so on. What total distance will the pigeon cover before the vehicles meet? Okay, so I've done a little drawing here to help illustrate the problem. So we have the car here and the truck here, and they are 55 kilometers apart, and it shows that the car travels at 80 kilometers per hour. Now both the car and the truck will meet at one point, right? This is the point. I'm highlighting it with the black point. So I've assumed that the car travels x kilometers and the truck travels 55 minus x kilometers, right? Now let's think about the bird. Now they say constant speed. What does that remind you of? URM. And what's the only equation we learned about URM? Delta x equals Vt. Now we have the V. How do we get the T? Well, now we look at the car and the truck. Now both of them travel for the same amount of time before meeting. So we have the distance, we have the velocity. How do we find time? T is equal to d over v. So what we do is x of the car, which is the distance traveled, over the velocity or the speed at, equals 55 minus x over 30. Since the times are equal, these also should be equal. Let's cross multiply. You guys can do all the calculations by yourself. What we should get is x to be equal to 40 kilometers. What does this tell us? That tells us that the car travels for 40 kilometers before it meets the truck. Well, that should help us find how much the car traveled for. For that, we need to do time for the car equals 40, which is the distance it travels, over the speed, which gives us half an hour. So the car has been traveling for half an hour. Well, now if we use this information for the bird, let's do it here. So delta x bird is equal to the speed of the bird times the time. Now we have the speed, which is 48 kilometers per hour, and we have the time, half an hour. So this shows us that the bird travels for 24 kilometers. When the bird has traveled for 24 kilometers as soon as the car and the truck meet. Okay guys, let's start number 9. The equation of motion of a particle is x centimeters equals 4 sine 8 pi t plus pi over 4. Part A asks us, find the angular frequency, the period, and the length of the line segment along which the motion occurs. I have given you some hints. You guys can solve it for a few seconds and then later we'll check. Okay guys, let's check it together. So from this we should immediately know it's simple harmonic motion. I have showed the equation as well. It's a sine omega t plus phi, a being the amplitude, omega being the angular frequency, and phi being the phase shift. So I have shown how simple harmonic motion works in a nutshell. Let's assume our particle starts at x equals 0, then it goes to plus amplitude, minus amplitude, and back, and then it goes back and forth, back and forth. So in the first question they're asking us, find the angular frequency. From the formula we know that whatever is next to the t is the angular frequency, and here it's 8 pi. So from automatically we see omega equals 8 pi. Next part asks us what's the period. Period is capital T. So what is the period? Well, we should remember from last year that omega equals 2 pi over t, right? So omega equals 2 pi over t. Substituting, we get 8 pi equals 2 pi over t. And when we solve, we get t equals 1 over 4 seconds, because that's the unit of period. So what the period means is the time it takes from 0 to plus amplitude to minus amplitude to back to 0. So one full cycle, the time it takes to complete that is the period. And the last part is the length of the line segment along which the motion occurs. So what is length? Let's represent this by L. Now the length is not 4 because it travels this and this. So length is always equal to 2 times the amplitude, which is 2 times 4 because length can't be negative, which is 8, and centimeters because it says centimeters next to x. So because it travels from here and here, so it's 4 plus 4. So you get 8 centimeters. Okay, let's continue number 9. Part B. Find the velocity at time t. I'll wait for a few seconds. You guys can all solve and then we'll check together. Okay, let's solve it. They're asking for the velocity and we have the position. Now, as we should all know, v equals x prime or equals dx over dt. So you're taking the derivative of x in respect to time because time is a variable here. So now, as we should all know, the derivative of sine u prime is equal to u prime cosine u, right? So now in this equation, 8 pi t plus pi over 4 is our u. So now pi over 4, you derive it, you get 0. 8 pi t, if you derive, you get 8 pi. So you do v equals 8 pi times 4, because the outside stays the same, cosine 8 pi t, because the inside stays the same, plus pi over 4. Let's simplify, which gives us v equals 32 pi cosine 8 pi t plus pi over 4. Now we should all remember that since position is given in centimeters, our velocity should be in centimeters per second. So the unit is a very important part of the answer, and this is how you get the velocity at time t. Okay, let's continue the question. We'll do parts C and D together. Part C says determine the position of the particle at time equals 0, and part D says determine the velocity of the particle at time equals 0. So I'm showing you both the equation of the position of the particle and the velocity of the particle, and you can solve it for a few seconds and then we'll check together. Okay, let's do it together. So when they ask for the position at time equals 0, all you have to do is substitute 0 in the equation. So here we have x equals 4 sine. So x at time 0, so we have to do 8 pi times 0 plus pi over 4. So this equals 4 sine pi over 4. Now you can solve in your calculators. Just be sure that this is, you have to use radians. You have to make sure your calculator is in radians mode, and you have to get 2 radical 2 centimeters. I got centimeters from here as the unit of position is in centimeters. And now let's do part D. Determine the velocity of the particle at time equals 0. Same thing. We have to do v equals 32 pi cosine 8 pi times 0 again because it's the initial velocity plus pi over 4 equals 32 pi cosine pi over 4, and this should simplify to approximately 71.1 centimeters per second. Okay, let's start with part E. What is the acceleration of the particle at time t? I've given you guys a hint here. I've given you the velocity. You should know what to do with that. I'll wait for a few seconds. You can all pause the video, solve, and then I'll check with you. Okay, let's check it together. As we all know, the acceleration is equal to the derivative of the velocity or the double derivative of the position. Now the format of the velocity is a cosine u, where u is something that you can derive. Well, as we all know, the derivative of this is negative a u prime sine u. So using this formula, what we should get is a equals negative 32 pi. Now when you derive all of this, you get 8 pi sine, and we keep everything the same, 8 pi t plus pi over 4. Simplifying further, we get a equals negative 256 pi squared sine, and we keep everything the same. But wait, we're forgetting something very important, the unit. The unit for a in this question is supposed to be centimeters per second squared. And there we have it. That's the acceleration. Okay, let's do parts F and G. Part F asks us, what is the velocity of the particle at x equals plus or minus root 7 centimeters? And part G says, what is the maximum velocity of the particle? I've shown some formulas on the board, and I'll wait for a few seconds while you guys solve. Okay, let's solve them together. Part F first. They're asking us for the velocity in terms of x. Now, we don't have the time, so we can't use our normal equation 32 pi cosine 8 pi t plus pi over 4. We can't use that. So what we have to do is, you have to use the equation that I'm circling right now. Because here we have velocity in terms of x. So let's substitute and see what we get. So v squared equals omega. The omega was the one that's next to the pi. So we got 8 pi squared, next to the t, sorry. 8 pi squared. Now the a was the term that is next before the sign, right? So a is 4. 4 squared minus root 7 all of it squared. After simplifying, we get 24 pi centimeters per second. So the simplification, I'm leaving it to you guys. You guys can do it. So you should get 24 pi centimeters per second. Let's go to part G. Now, what is the maximum velocity? Again, V max, as we can see on the board, is equal to A omega. Now, let's substitute again. 4 times 8 pi, which equals 32 pi centimeters per second. So, as we can see here, the maximum velocity which the object will get is 32 pi centimeters per second, and at the position x plus minus 7 centimeters, the velocity of the object will be this. Let's do number 10. Let's read it together. A body moves in simple harmonic motion along a straight line of length 12 centimeters. At time equals 0, the body is at one extremity of the trajectory in the positive sense. The body makes 8 complete oscillations per second. Part A. Write the equation of motion of the body. I've written some notes here. You can use them while you solve the question, and after a few seconds, I'll check with you guys. Okay, let's do it together. First, let me explain this line I've drawn, the red line. As we all know, it's simple harmonic motion, so it should have an extremity with the plus amplitude and the minus amplitude. We know the length of the total segment being 12 centimeters, and we know that at time 0, the initial position is at x equals plus amplitude. It's at the positive end of the line, you could say. We also know, because of this statement, 8 complete oscillations per second, that the frequency is 8 hertz or 8 seconds inverse, right? Part A asks us, what's the equation of motion of the body? As we all know, x equals a sine omega t plus 5 phi. Well, we can get A very easily. We know that 12 is the whole length, and we know that this whole segment is half of the length. So instantly we know that A is equal to 12 over 2, which is 6 centimeters. So we already have one part of the equation already solved. Omega is also very simple to find. Omega is equal to, as we all remember, 2 pi f. F being the frequency, so 2 pi into 8, which is 16 pi. So we have A, we have omega. What's left? Phi. How do we get that? It's not given in the equation, nor can I get it from the drawing. Well, for this, you have to look at this line. At t equals 0, the body is at one extremity of the trajectory. To find phi, we substitute in the equation. So we use x is equal to 6 because it's at the extremity, equals 6 sine 16 pi into 0 because the time is 0 plus phi. Now 6 cancels, this is 1, and this is also cancelled because it's 0. So in short, what we get is sine phi equals 1. Now everyone can do shift sine 1, and we should all get 90 or pi over 2. Now which one should we use? Should we use 90 or pi over 2? Definitely pi over 2, because everything we've been using so far is in radians, so this also has to be in radians. So the final equation, this I'm going to write in red, is x centimeters equals 6 sine 16 pi t plus pi over 2, and that's the final answer. Let's do part B now. Determine the velocity of the body at time equals 1 over 8 seconds. So I've given you the position, the equation of position, and now for a few seconds you guys can solve and then we'll check together. So as we all know by now, the velocity is the derivative of x, or the position, and it's very easy to derive this. It's 96 pi cosine 16 pi t plus pi over 2. For those who didn't understand what I did was derivative of sine a sine u is equal to a u prime cosine u. But that's not the whole question. What they're asking for is at time 1 over 8 seconds. So that's very easy. All you have to do is substitute 1 over 8 here. So let's do that. V equals 96 pi cosine 16 pi times 1 over 8 plus pi over 2. Make sure that your calculator is set to radians, and make sure that the answer you get is 0 centimeters per second. So this is a very special time. So at time 1 over 8 seconds, our particle is at rest. Okay, let's start with number 11. A body moves in simple harmonic rotational motion of amplitude 3 revolutions and frequency 1.5 Hz. At t equals 0, theta equals 3 pi radians. Part A. Determine the amplitude in radians. B says find the angular frequency. C says the phase. And D says what's the equation of motion. Now the only difference between angular simple harmonic motion, which is simple harmonic rotational motion, and simple harmonic motion is that the units change. So as we all remember, the equation of motion for simple harmonic motion was x in centimeters or meters equals a sine omega t plus phi, right? Now the only difference it becomes is theta, which takes the place of x, in radians, again equals a sine omega t plus phi. That's the only difference we have. So using this knowledge, I'll wait for a few seconds, all of you can solve, and then we'll check together. Okay, let's do it together. So part A asks us what's the amplitude in radians. Now they've given us the amplitude in revolutions. What does that mean? Well, let's think about the circle I've drawn here. Let's say we start at this point, which I'm highlighting with black. I'm making it very big. And let's say I go all the way around the circle and come back to this point. What's the distance I've covered in radians? I've covered 1 revolution, right? But what's the radians? 2 pi radians. So what we get from this is 1 revolution is 2 pi radians. So using this basic conversion factor, what we can do is 3 revolutions times 2 pi radians over 1 revolution, cancel the revolutions, you get amplitude equals 6 pi radians. Let's go to part B. Find the angular frequency. Very easy to do, is the exact same formula and we have the frequency. So all I have to do is omega equals 2 pi f, which is 2 pi times 1.5, which gives us 3 pi radians per second. Or if you want to keep significant figures, you can do 3.0 pi radians per second. Let's shift to part C, which asks us what is the phase at time equals 0. Now one critical given that we have seen, let me go back, is that at time equals 0, theta, which is this theta, which I'm circling here, is 3 pi radians. Now we have the amplitude, we have omega, we have time. All you have to do is find phi. So using this equation, we get 3 pi equals 6 pi sine 3 pi times 0, because they want at time 0, plus phi. Well, let's simplify. This becomes half. So half equals sine phi, because this whole thing cancels out. Now let's do shift sine half. Again, make sure your answer has to be in radians, and you have to get pi over 6. You get 30, you have to convert, and then you get pi over 6. Part D is again very easy. All they're asking us to do is assemble everything we've gotten so far and we have to give them the equation of motion. So again, using the same equation, theta in radians, so again you have to put the units, 6 pi sine omega t, which is 3 pi t, plus phi, which you've gotten from here, pi over 6. And that's the equation of motion. Let's continue with parts E and F. Part E says find the angular velocity at time t, and part F says find the angular velocity at time equals 2.5 seconds. So I'll wait for a few seconds. I've given you the equation of motion for the angular simple harmonic motion, and we'll check after a few seconds. Okay, let's do it. Now find the angular velocity. As we all know, velocity is the derivative of the position equation. So what you have to do is we can either do omega prime or we can do d omega over dt. Now if we remember a sine u, the derivative of that was au prime cosine u, right? So again, using that same equation, we derive only this part. The derivative of this is 0 anyways. So we take 3 pi out and we should get 18 pi squared cosine 3 pi t plus pi over 6. Now we don't put radians per second here, we can just put it here. So the whole thing is radians per second. So this is your angular velocity at any time t. Now let's go to part F. Part F is extremely simple. All they're asking us to do is find the velocity at this particular time. So using this equation, all you have to do is substitute 2.5 in t. So that's what we're going to do. 18 pi squared cosine 3 pi times 2.5 plus pi over 6. Again, making sure that our calculators are in radian mode, and we should get around 88.8 radians per second. You just have to substitute in your calculator and you should get this answer. 88.8 radians per second.